What's up? What's up? What's up? It's your boy, the network. Today's topic is Describe Dm Vpn Single Hub, Section 4.2 of the CCNP route exam. This will be known as the CCNP Enterprise exam. So this topic most likely will be in that exam. It's just the code is different. This is the exam code 300-101. That exam code may be different as well. Let's take a look at the exam blueprint to see where we came from and where we are headed. Hashtag labeveryday. All right, this is the exam blueprint, implementing Cisco IP routing, exam code 300-101. Again, this will be called the CCNP Enterprise exam. So if you do run into this, just know that it used to be called the CCNP route exam, and basically they just changed some of this stuff up. But most likely this topic will be in that new exam. So most likely it'll be applicable because I'm pretty sure Dm VPNs will exist. We just covered configuring and verifying GRE tunnels. Today we are going to describe. Notice this says describe. So we really don't have to do any configuring or know how to do know too much about verifying and stuff like that. But we are going to fire at Boson Netsim and do a little bit of configuration with Dm Vpn. So it says here we just needed to describe it, but we're going to play with a little bit of hands-on here. After that, we're going to move on to describing EN or EVN, Easy Virtual Networking. So what is Dm Vpn? Before we even describe Dm Vpn, let's talk about VPNs in general. Now, when I think about VPNs, I wish I explained this in the last video. It's similar to GRE tunnels, but when I think about Dm VPNs, I don't know if y'all remember this show. This is called The Cone of Silence. This show is called Get Smart. This is a show from like the early, from late 60s up to like 1970 or something like that, right? And basically, these two guys, so this guy on the right-hand side, that's Maxwell Smart. That's the boss's name. I can't remember. That's y'all pop quiz for today. What was the boss's name in Get Smart? Anyway, anytime they had some kind of confidential information they needed to share, they put these two little things on their head. It's called a cone of silence. And then they would speak amongst each other through this little tunnel right here, and nobody could hear them, right? I know. This is basically... They didn't have VPNs back then, and this is what they used to keep their information confidential rather. Anyways, this is similar to how a VPN works. You got a client and another client, and they would speak amongst each other. Same thing with GRE tunnels. They would speak amongst each other within this little tunnel here, so nobody else could hear them. Right now, that's how a VPN or a general VPN would work. Right now. Take this concept, and we're going to talk about Dm VPNs. Dm VPNs will be like say the boss, he's talking to Maxwell Smart right here, right? Let's say we had another agent over here, and the boss needed to talk to him, right? This cone right here would be detachable, right? Or this little tube right here would be detachable. If he wanted to talk to the other agent, he would take this cone off, or this tube off, and talk to the other agent who has a cone over his head, and talk to that guy, right? Let's say we had 50 agents that the boss needed to talk to. He would take this tube and talk to every time he needed to talk to another agent, he would take the tube off and talk to another agent, talk to another agent, talk to another agent, rather than having 500 or 600 whatever tubes to talk to each one of these agents. Otherwise, those would be static, right? It's called dynamic because anytime he needed to talk to another agent, he would take this tube off and talk to another agent rather than have a static, that don't even look right, a static tube for each little agent. Let's head over to the next definition, or next slide for an official definition. So a Dm VPN is a dynamic multi-point virtual private network. It's a dynamic tunneling form of VPNs. So just like we said, but it's just like VPNs, but it's dynamic because it would be static if he has the cone, like the tube attached, right? That would be a static connection. The dynamic connection, if the tube is detachable, and you can talk to everybody else, right? It's supported on Cisco iOS based routers, Huawei routers, and USG firewalls, and on Unix-like operating systems. So I think my daughter's awake now. We have the headquarters router right here, and needs to talk to branch 1 and or branch 2. He has a tunnel connected to the cloud right here. And if he needs to speak to branch 1, he has this dynamic tunnel here. So this will be like a detachable tunnel right here. And if he needs to talk to branch 2, same thing. He has a detachable detachable tube to talk to this guy. If he had, and this is scalable because if he had 500 other spokes, this would be considered your hub, and this would be considered your spokes. So if he needed to speak to these other spokes, he would just take this detachable cone or detachable tube and talk to the other guys. It's just that you would have a private IP address mapped to another IP address. So if he says, if you see right here, branch 1 says, I want to tunnel something to branch 2. So we could have our spokes speak to another spoke, and that's how Dm VPNs work. So we could have our agent speak to another agent, and he doesn't necessarily have to talk to the hub to get to him, but he will have to get some information from the hub or headquarters or the boss because he has the mapping information. So it's similar to frame relay. A couple fun facts about Dm VPN. Dm VPN is a Cisco feature that dynamically creates mesh VPN network. This helps to avoid having to statically create VPN tunnels for a mesh network as the network grows in size. So if we had only 2 agents that we needed to speak to, that's fine and everything. If we had 500 agents, you know, we can take this detachable cone or detachable tube to talk to everybody else, right? Dm VPN would dynamically create VPN tunnels as they are needed. So basically, we're taking these detachable tubes to talk to them, and we just pull it out every time we need to talk to anybody else, basically. This works by creating a logical hub and spoke topology. Each spoke creates a multiple GRE tunnel back to the hub, or Mgre. We're going to fire up Boson Netsim, and I'll show y'all a basic topology on how this works. The hub then uses next hop resolution protocol. So this is another routing protocol that we're going to use. Well, it's not really a routing protocol. It's a protocol that we use to for Dm VPNs to map each spoke's tunnel IP address to its public IP address. So it's similar to frame relay, how we map DLCs to IP addresses, right? Same thing, but except we're mapping public IP addresses to the tunnel IP addresses, which is mostly or normally private IP address. So when one spoke needs to send traffic to another spoke, it queries the hub. I'll show you when this spoke needs to speak to that spoke, he queries the hub with Nhrp to get the physical IP address of the other spoke. So when he needs to get that physical IP address, he asks him, hey, what's his physical IP address? Using Nhrp. This allows him to create a dynamic tunnel. So then we'll have a tunnel between these two guys right here. Not necessarily a tunnel here, but he will query him for the IP addressing information to create a tunnel with this guy. And that would be a dynamic tunnel here. Dm VPN has 3 phases. Again, we're just describing Dm VPN, so we're not going to do all 3 phases. Obviously we need to know all 3 phases, but CCNP only requires us to know to describe Dm VPN. We're just going to describe phase 1 right now, hub and spoke only. So let's go ahead and fire up Boson Netsim and cover phase 1. So here is the route lab, Dm VPN phase 1. Our objective is to plan and configure Dm VPN, basically, phase 1. So here's the topology. We've got the hub right here. This would be kind of like the boss. This would be like Maxwell Smart, right? And this is another agent we got right here. Don't worry about the RAN router. We are going to just configure, do the configuration on the hub and the spokes right here. Here's some basic some basic commands that we'll need to know. Some IP address. We know how to configure an IP address. This is the command we use to map. I wish I had put that in the slides here. To map IP addressing to the Nmba address. Here goes a couple show commands. And here's the IP addressing guide. Again, this is the topology right here. We got the hub, spoke 1, and spoke 2. This wants us to verify the initial configurations. I'm not going to do too much of this. We'll just do one of these, right? To verify the IP addressing information, we know it's show IP interface brief, but we'll do it anyway. Enable show IP interface brief. We've got the serial IP address. This is the physical IP address, right? 72.77, 172.106. Then we have a loopback on the hub router. I'm not going to do the same. All the IP addressing is already configured. I'm not going to do all that right now. Reviewing Dm VPN, we're not going to review any of the concepts. I gave you our basic analogy at the beginning, so we'll skip this part as well. we'll do a basic connectivity between the hub and spoke 1. So basically they want us to, on the hub, verify connectivity with both spoke routers. Spoke 1 issuing a ping to spoke 1 serial 00 interface. So on the hub, we need to ping that right there. Let's go ahead and do that. Ping, just so we know that it works. 65.103.2.58. I guess that's the beauty of using simulators, because all of this is set up for you. Now, I'm going to be practicing some of this stuff with hardware. I suggest you do the same thing. If not, then create your own topology using GNS3, because all of this stuff is laid out for us. It helps with troubleshooting when you can build this stuff from the ground up. But for me to explain it and make it quickly, that's why I use these simulators. Notice that the ping worked. We'll do the same thing with spoke 2 as well, just so we know that it works. We're going to issue a ping to 216.72.8.85. That also worked. So both pings should be successful, and they did. We're not going to review Dm Vpn. Like I said, we already covered a basic analogy right there at the beginning. Configure Dm Vpn on the hub router. So we're on the hub right now. Create a tunnel interface with interface number 0. We learned that on the last video, configuring GRE tunnels. We're going to go to global config mode, interface tunnel 0. That's created a tunnel, but notice it changed the state to down, so it is not completely up yet, right? Configure interface tunnel 0 with appropriate IP address and subnet mask. Refer to the IP addressing table. So we're going to go here, and he says on the hub, tunnel 0 needs to be 10.0.0.1/24. So IP address 10.0.0.1. The subnet mask is /24. Next task, he says to configure the source, the tunnel source on interface tunnel 0 to use serial 00. Now, I didn't really know you could do that, but yes, that's what we're going to do. We're going to do the tunnel source as serial 00. So we're going to say serial 0/0. That's the source. Configure interface tunnel 0 to operate in Mgre mode. Now, I forgot to show you guys the mode in the last video for GRE. We can do tunnel mode. That's how we do it. And then here's the modes we can do. And they said they want us to do what? Mgre mode. Do you see an Mgre mode here? I don't, but we know that it's GRE. So that's M or GRE. What else can we do here? It says multi-point. So Mgre is multi-point. But we did say in the slides that Mgre is multiple GRE tunnel. So we have, it creates a multiple GRE tunnel back to the hub. And that's what essentially we're doing here. So tunnel mode, Mgre, or GRE multi-point. And that's basically it. That's how come you don't really have to memorize all these modes or commands and stuff. You can question mark, and I believe you can question mark on the exam as well. You just need to know the concept here. Configure an Nhrp network ID of 1 on interface tunnel 0. So how do we do that? I believe we stay on the tunnel, IP Nhrp, and he says a network ID of 1. So notice here, network ID. So network ID is 1. Question mark for y'all. That's the network identifier. That looks like an infinite metric for Eigrp, right? So network ID of 1. Configure interface tunnel 0 to dynamically learn multicast destinations from the spoke router. So we're going to say IP. He says learn multicast destinations. I believe it's Nhrp. Is it Dm Vpn? Nope. I don't really know. Let's go ahead and look at the addressing guide. Well, actually, let's see. IP Nhrp map. And then CC right here. Dynamically learn multicast destinations. So dynamically, right here, use this for Nmba broadcast or multicast. So we're going to say multicast. And then he says dynamically learn them. So multicast, dynamic for dynamically learning them. Learning destinations from clients. Dynamic. What else can we do here? And that's pretty much it. That's all we needed to do, believe, right there. Configure tunnel 0 and loopback 0 interfaces to participate in the Eigrp routing. We know how to do that. You should use AS100, disable auto summarization, and disable routing updates on loopback 0 interface. So we're going to go to, We just need to configure Eigrp. So we're going to router Eigrp. He says AS100. What is the addressing for? What is the IP addressing? So we need to know the IP address for tunnel 0 and loopback 0. Did we do the IP address of tunnel 0? We did. We did. We said the IP address was in the 10 network. So we need to do 10 network. What was the loopback interface? As 1. So this is the 1/32 network. So that is going to be, we need to have them participate in the Eigrp by doing the network command. 10 network, it was /24. So we do 10. The wildcard mask for /24 is 000.255. Do anything else, that's it. And then to add the loopback, we say network, and it was quad 1 network. And it's /32, so we do just quad 0. Now those two should participate in the Eigrp. Disable routing updates. Oh, disable auto summarization. We know how to do that. That's no auto summary. And he also said to disable routing updates. How do we do that? Passive interface. If you don't know that, go on my CCNP playlist. I did a video on troubleshooting passive interfaces and what passive interfaces are. No, we just do passive interface, loopback 0. So now loopback 0 is a passive interface. Disable split horizon. I also did a video on that. Check my CCNP playlist and look at my channel. You'll see a video on split horizon. I did a perfect explanation on what split horizon is. Tunnel 0 for the Eigrp routing process. We need to go to tunnel 0. I don't think we can do it on the router config mode. So we go to tunnel 0 interface, tunnel 0, and we say no IP split horizon Eigrp 100. And that disables split horizon on interface tunnel 0 for the Eigrp routing process. I used to think you had to go on a routing process to do it, but no, you got to go to the interface. Now, here's the meat and potatoes of what we wanted to do. Configure Dm Vpn on the spoke routers. So we're going to go to spoke router. This task involves configuring Dm Vpn phase 1 on the spoke routers. On each spoke router, configure a static tunnel 0 interface. So let's do that. We're going to go with tunnel 0 interface, right? So we're going to go to privileged exec mode, global config mode, interface tunnel 0, and he says do the same thing on spoke 2, privileged exec, global config, interface tunnel 0. All right, and then he says set the appropriate IP addresses from the IP addressing table. So we need to go back to spoke 1 and do the IP address for tunnel 0. Where's that at? Tunnel 0's IP address on spoke 1 is 10.0.0.2. So we say IP address 10.0.0.2, 255.255.255/24 basically. Do the same thing on spoke 2. So we're going to go to spoke 2, and that's the IP address 10.0.0.3, 255.255.255.0. Set the tunnel source of 0.0.0 on both routers and the destination as 72.77. Now this is on both routers. So basically we are creating the source as a serial interface on both guys, and the destination is going to be 72.77, 172.106, which is basically the hub router. Let's double check that, right? Yes, it's the serial 00. So we're creating the source as their serial interfaces and then the destination as the hub serial interface. So let's do that on spoke. Let's start with spoke 1 so that we go in order. Tunnel source is serial 00. We're going to do the same thing on, and then the destination is 72.77.172.106. That's it. We just need to do IP address. That's it. We don't need to do subnet mask. Do we? My bad. We forgot destination right there. Destination. Do the same thing. Now notice it's up. Tunnel 0 is up on spoke 1. Let's do the same thing on spoke 2. Tunnel source is serial 00. Tunnel destination. So this is similar to the GRE tunnels, right? Except that we're creating multiple GRE tunnels and they're dynamically assigned. Because remember, GRE tunnels, they're static. Destination is 72.77.172.106. Y'all with me so far? That's the destination, right? So the destination, and notice is up. The destination from spoke 1 is that guy, that 72 address, and the same thing with spoke 2. The source is their serial interfaces. That's what we did right there. Now, he says here to configure an Nhrp network ID of 1 on internal 0 interface on each spoke router. Basically what we did on the hub router, right? So IP, Nhrp, network ID is 1, and we do the same thing on spoke 2. IP, Nhrp, network ID 1. Configure each spoke router to use hub as the next hop server. What's the next hop server? Basically, he's saying, in other words, like here's an example. If spoke 1 wants to speak to spoke 2, he needs to know what's his next hop to get there. Well, we're going to define the hub as the next hop. So we're going to say, this is your next hop to get to spoke 2. So we need to configure each spoke router to use the hub as the next hop server. How do we do that? IP, Nhrp, right here, specify a next hop server. NHS. So how do we know what's the IP address of the next hop server? Is it the public IP address or the private IP address? We already said the tunnel destination was the public IP, right? The 72.77. So now the next hop is going to be that tunnel, the dynamic tunnel that we create. So what is that? The hub says the tunnel's IP address is 10.0.0.1. So NHS is the next hop server, and we're saying 10.0.0.1, right? Because we already made the destination, the tunnel destination was the public IP address. Now we're saying the next hop server is that private IP address. So we got to do the same thing. We did that on spoke 2. Right now we're going to do that on spoke 1. IP, Nhrp, next hop server, right? I'll show you again. NHS specifies the next hop server. And when we do that, we're saying his next hop is the hub. NHS 10.0.0.1. Y'all with me so far, right? So now it says here, configure each spoke router with a static Nmba mapping for the destination IP address to the next hop server. Now this is a little bit confusing here. Configure each spoke router with a static Nmba mapping. HRP. There we go. Map destination IP address to NBMA address. So we're going to say map and the IP address of the destination, which I believe is the physical IP address we're going to do here. So the IP address of the destination. Let's look at the addressing, the answering guide, because I can't remember. I'm not gonna front for y'all here. Yes, so we're gonna map the private IP address to the public. That's basically what we're doing with the mapping here. So it's just like mapping IP addresses to DLCs, right? But this is just for the hub from the spoke. Okay, so we're gonna spoke 1. We're gonna map the IP address 10.0.0.1. We're saying we're mapping the public or the private IP address to the public IP. So 72.77.172.106. We're going to do the same thing on spoke 2. IP Nhrp map 10.0.0.1 to 72.77.172.106. And look who's awake, y'all. It's my daughter. Say hi to everybody, Eleni. Say hi. We're going to finish. We're doing Dm VPNs. Are you interested in that? Do you like Dm VPNs? I guess not, y'all. All right, so we're going to configure, now it says here, to configure tunnel 0 and loopback 0 interfaces on each spoke router to participate in Eigrp routing. So we're basically doing Eigrp right here. We're going to go to spoke 1 and do the same thing what we did on the hub, right? But except we're going to configure Eigrp. You want to go to the pool today later? Okay, we'll go later. You want to play for a little bit? Yes, I got the jellyfish. And we can bring the boat too if you want. Dora. And Dora if you want. We can bring Dora, jellyfish, or the bed, or the boat if you want. So we're going to go to router Eigrp 100. We want the loopback. We need the tunnel and the loopback interfaces to participate in Eigrp. What was their interfaces? Let's double check though. Do show IP interface brief. The interfaces was quad 2 and 10 network. This is /32 and this is /24. I already looked it up. So we're going to say network 2.2.2.2 /32. So we're doing the wildcard mask, quad 0. And then we're going to have the tunnel participate in Eigrp as well. So network to 10 network /24, which is quad 0.255. Remember, these are wildcard masks, and that's the wildcard mask for /24 network. So we got those two to participate. Notice we have an Eigrp adjacency. What adjacency do we have here? This is weird, right? Neighbor is 10.0.0.1. Who is that? That's the hub. So now these two are Eigrp neighbors. Isn't that cool? And we did that through the Dm Vpn tunnel. Now he wants us to, he said the Eigrp, we need to disable auto summarization, disable routing updates, disable auto summarization. How we do that? No auto summary, that's a fundamental. And disable routing updates on loopback 0. We're going to disable the routing updates. How do we do that? Same thing, we go to the interface. We're going to say interface loopback 0. Disable the routing updates is passive. No, we need to stay on the routing. We need to stay in the routing process. Remember I said that last time. Router Eigrp 100. Router Eigrp 100. And we want to disable routing updates on loopback 0 interface. So passive interface loop 0. Now we've disabled routing updates on that. We're going to do the same thing on spoke 2. This is basic Eigrp stuff right here. Router Eigrp 100. And we're saying the network was for the loopback interface. Let's double check though. Do show IP interface brief. Loopback is quad 3. Tunnel is in the 10 network. So network 3.3.3.3. It's /32, so quad 0 is this wildcard mask. Network 10 network, and the wildcard mask for /24 is 0.0.255. Notice we have a new adjacency. Who is that adjacency? 10.0.0.1, which is the hub, through tunnel 0. That's our new adjacency. So now spoke 2 is a Eigrp neighbor with the hub. Now they also want us to disable auto summarization and routing updates. So no auto summary, and the routing updates is passive interface loopback 0. So now we've disabled routing updates. Now task 5 says to verify Dm Vpn. On all 3 routers, we need to verify that both spoke 1 and spoke 2 has formed a dynamic tunnel with the hub. How do we do that? On spoke 1, we do show Dm Vpn. It's simple as that. Okay, so now we do show Dm Vpn, and if you notice here, here's the legend right here. We've got interface tunnel 0. We've got a spoke. Spoke 1 is obviously a spoke. We've even named the host name that. And one peer. So his Nhrp peer is the hub. Now, if we wanted to, we can make spoke 2 appear as well, but that is just, I believe, phase 2 or 3 is how we can make the other spokes peers. But right now, only he is a peer. That peer is this guy right here, 72.77, which is mapped to the 10.0.0.2 update. It's up for 1 minute. We can run it again and see 1:51. See? It's been up for 1 minute and 51 seconds. We can do the same thing on spoke 1. Let's actually take a look at the hub and see what's different. Notice the 2 adjacencies. It did. What? Y'all know y'all gotta. We gotta entertain her as well. So we got an adjacency with that guy and this guy. So that's our spokes right there on the hub. And if we also do show Dm Vpn, and he has 2 peers, as you can see. So this hub has a peer with that guy and a peer with this guy. And that's why we have 2 hubs there. 65, that's the public IP address. And this is the private IP address that we created. Notice the D, what's that? It's dynamic. What does dynamic mean? It's basically the tunnels are dynamic. They're detachable. That's how we can remember it. These tubes that we created are dynamic. They're detachable. And it's up. And we can verify that by just pinging those guys 10.0.0.2. My bad, we forgot to add another .2. And it came back up right here. Or it came up, and we can ping the other guy. So basically we pinged spoke 1, and we could also ping spoke 2, which is 10.0.0.3. And we got a reply there as well. They also want us to, we issued pings to all those guys. Those pings can work reversible as well. They also want us to tell us what's the difference between static and dynamic. Basically, a static designation. So if we show this command again, show Dm Vpn, they want us to know what the static designation for the peers are, right? Where's that at? So static would be like if the cone or the tube is not, it's attachable. We can't remove the tube. It's static. It's detached. Once it's detachable, then these are dynamic. So anytime we need to speak to that spoke, we can take the tube and connect to it. We want to speak to that one, take this tube off and connect to that one. That's basically what the difference between static and dynamic designations are. That's all I got for y'all today. That is my YouTube page. That is my Twitter handle. Go ahead and add me on Twitter. Please leave a comment below on how I can explain this a little bit better, or if you feel like I made any mistakes, or I could have, or if you like this video, please put a comment below. If you do like it, click the like button right there. If you want to subscribe, go ahead and subscribe. There's also a notification bell that lets you know when I put some more videos up. So please, in other words, comment, like, subscribe to the network.